Okay, so this is our last topic po kahapon. Okay, so we have here the sample problem. We have the simply supported beam, okay, and then loaded with 2,000 pounds. Okay, 3 feet from one end of the support. Okay, and then given initially the rectangular cross section 2 by 4. Okay, so from the cross section we solve for C and the I value. Okay, and then using table 82 naman po. Okay, so meron po doon na katulad ng loading na to, so we simply adopt po yung equation po doon, FAB over L. So we come up with the maximum moment. Okay? So you have here po yung dalawa, okay, ay yung C and I and the maximum moment. Then we substitute that to the flexural stress formula, MC over I. Then we arrive at 10.125 KSI. Okay? So ito po yung first part ng problem po na natin sa pure bending. Okay? And then I have given you po yung kadugtong po nito. Okay? That would be the design part. Given a certain material, okay, I think that is C1050 as roll, okay, you have to find the factor of safety to be used, okay, assuming that design is based on the yield strength and the ultimate strength, okay. And then the second one is for you to resolve this problem using a different po na using a different cross-section na po. Okay? So, this time po, ang gagamitin natin is yung cross-section na sinolve natin on the economic section, which is letter C. I think doon sa grupo niya, tama po ba? Hello?
Yes, ma'am.
Yes,
Okay, so
ma'am.
I hope you save po yung value or yung copy nung solution po natin for that C cross section. Okay? So, let us have now po your solution, okay, on the design part po ng sample problem po na ito. Okay? So, I'll send to you po a link for the Jamboard, and then let us see your answers po doon. Paki-paste na lang po for our discussion. Okay, so I have shared to you po the link for our Jamboard. Okay, kindly join na lang po. Okay, and then I'll be presenting po this Jamboard of ours po.
Ma'am, hindi ko lang po sure kung sa akin lang po, pero naka-view only lang po yung Jamboard ko.
Parang naano ko na siya, na i-update ko na. Kindly check ulit. Baka una ka nag-view kesa doon sa napalitan ko. Okay, try to recheck. Yan, okay. So, I'll have this slide muna po. Okay, aray po muna. Okay, so for number one, you're asked to find po the factor of safety, okay, based on different design ano po natin, okay, whether it's ultimate or the yield strength, okay. So, we start muna po with the given values, okay. So, kunin lang po natin is yung answer po natin from yung previous po natin na solution. Ilagay ko muna po dito as given, and then i-follow na lang po natin yung essence po ng design in solving the problem. Okay? So, doon po, ang nakuha po natin is simply the value of deflectional stress. So, yeah, come up with 10 0.125. Kindly check po ha kung tama yung inilagay ko. Then 0.125 KSI. Okay, again, this is taken from our previous solution. Okay, doon po yun kinuha. Yan. So, you have here yung given, and then we go now with material specification. Okay, so material specification, we have AISI C1050 as road. Okay, so you find the value of sigma U and the sigma Y value, okay, and then the reference table, okay, and the page number. And then after material specification, okay, mamaya po mag-ano po tayo dito, mag-show po tayo ng samples ng ginawa mo, okay? So ito po ay ninanarrate ko lang po as to the procedure that you will be applying, okay? Following the procedure po ng design, okay? After material specification, we go with the factor of safety, okay? So this time po, on our factor of safety, okay, this is unknown, okay? So siya po yung unknown dito sa problem, okay? And then we come up with the design stress. Okay, so for letter A, base design on ultimate, we say sigma D is equal to sigma U divided by factor of safety. Okay? So, ang pwede lang po naman natin mapalitan dyan is the value of sigma U. Okay? And for letter B, that would be based on sigma Y. Then the design stress would be sigma Y over factor of safety. Okay? And then kasunod na po niyaan, okay, is of course equating the design stress to the induced stress of the material. Okay? So kasunod na po nito for a good design. Okay? We then equate, okay, design stress okay, equate now the design stress to the induced stress of the material. So the induced stress, ito na po yung ano po natin, ipapalit po natin, okay? And then sigma U is given, therefore you can solve now for your factor of safety, okay? So ganun lang din po yung gagawin natin for your sigma Y, okay? And then the value of the factor of safety, kung ano po yung makuha natin, yun po natin na answer, wala na po tayong i-convert pa to the whole number, okay, as it is na po yun. And then for number 2 naman po is for you to resolve, okay? Pag ni-resolve naman po siya, yung pong ito pong sigma F, okay, magsisimula po tayo dito. Kasi nagbago po tayo nung cross-section. It is no longer the rectangular cross-section, but then we will be using na po yung C cross-section po natin. Okay? So let us see po yung inyong pong answers. Okay, so ito na po yung ano natin. Okay, so kaya ko po sinow po itong procedure, okay, para you would follow po. Okay, so ito po yung ifa-follow po natin. Pagkatapos po na rin ng for a good design, okay, tsaka po dapat lalabas po aring design stress, okay, equal to your flexural stress. Okay, ito po. And then you come up with the value of factor of safety. Okay, Chavez, kindly explain po your work for letter A. Hello? Chavez? Uy, narinig po ba ako?
Naririnig po.
Chavez? Okay. Nasaan po siya? Wala? Wala po si Chavez?
Ibang block po ata yan, ma'am.
Ma'am, ibang jumper
Zero one po ata yan.
Ano, anak? Ito yung kanina ko pa. Ano?
Sa 01 po ata yung ano.
Ibang block po kami nakapresent po.
Wait lang. Dali ang present. Dalawa pala to. Wait.
Okay, ito na daw po ang inyong banana cue. Wala lang si Ate Worm.
Okay, so let us have this, Miss Pelares. Kindly explain po your work, okay, for the factor of safety based on the ultimate strength. Miss Pelares.
Yes po, ma'am.
Are you around?
Yung sa number 1 po ba?
Yes po.
So for a good design po, we're going to equate the design stress and the fluctual stress. So first wise based sa ultimate strength. So ang formula po for design stress based on ultimate strength po ay sigma u over fs is equal to fluctual stress. Then equate and i-derive po yung formula ng fs magiging sigma u over fluctual stress po, which is equal to 102 KSI over 10.125 KSI. Thus, our factor of safety po based po sa ultimate strength ay 10.07 407407. Then based naman po sa yield strength, same ang formula naman po is factor of safety is equal to sigma y over fluctual stress, which is equal to 58 KSI over 10.125 KSI is equal to 5.728395062. Yun lang po, ma'am.
Okay, thank you, Miss Rose. Okay. So, next naman po, okay, so we yield po 10.07, okay, and then the other one is 5.73, okay. So, I see naman po all answers yield to that value po, okay. So, simple naman po lang yung gagawin natin, that is equating the design stress to the induced stress of the material, okay. And then, we have po our initial po na solution on the CEQA section given. Okay, so you have the economic section wherein we obtain here C value is equal to 2.5. So yun po laging tatandaan natin. If it is symmetrical po, okay, the neutral axis will be at the center po. Okay, so you simply take half of the total height, okay, that will give us the value of your y bar. Okay, so yun po yung gagamitin natin. So ang gagawin lang po natin on the number 2 is that ang papalitan po natin will be yung cross section. So you will be resolving again for the flexural stress, okay? Tapos tsaka po ulit natin siya i-equate to the design stress, okay? So yun po yung gagawin natin. Okay, let me check muna po sino yung pwede mag-present po dito. So, medyo malinaw po yung solution. Okay, Aguila.
Yes po.
Okay. Try to explain your work. Okay, for number 2.
Okay po. So,
So for number 2, we're going to solve the problem using the given economic section. So ang gagamitin po nating values na ng C and I ay yung nakuha po natin dun sa C-beam natin. So for the formula of flexural stress, sigma F is equals to MC over I. So for 1,500 pound-feet times 2.5 inches, ay yung pound-feet po ay convert natin. Then, so, ang value po na nakuha natin for flexural stress ay 3866.348449 pound per inch squared. Then, PSI, so convert po natin sa KSI, then magiging 3.866348449 KSI. Then, for a good design naman po, equate lang natin yung design stress nakuha nating value ng flexural stress. So, sigma D is equals to sigma F. Then, based on ultimate strength, we have sigma U over factor of safety is equals to sigma F. Then, the value of sigma U from our table 88 page 16 which is 102 KSI, then divided by Fs is equals to 3.866 KSI. So the value of the factor of safety is equals to 26.3814848. Then based naman po sa yield ay we have sigma Y over Fs is equals to sigma F. Then the value of our sigma Y is equals to 58 KSI, which is from table 88, page 16 also. Then, over Fs is equals to 3.866 KSI. So, ang value po ng Fs natin ay equals sa 15.001-23457. Yun lang po.
Okay, thank you, Ms. Janela. Okay, do you yield the same answer po? Okay, so ang sabi ko nga po, ang difference lang po nito, okay, is kukunin natin yung initially solve natin ng C and I value. Okay, to come up with yung conventional stress. Okay, the same po na po ang sagot. Hello?
The same po, ma'am.
Yes po, ma'am.
So, we have a question po. Okay, so, ang medyo ano lang po dito, okay, ang balikan nyo lang siguro dito, kasi dito sa sample natin, we were not able to record po yung paggawa ng bowel movement. Okay, what we have here po is we obtain the maximum moment using the table 82. Okay, so siguro po, doon na lang po kayo kasi doon na lang din po siya mag-iiba. Okay, kung wala po doon yung equation, then the only thing that you do is to create a shift moment diagram. So, pakibalikan nyo na lang po on your notes po sa mechanics of the okay? And then another thing is, what if yun po these are ones ano, okay? Kumbaga, yun po, then po letter C. So, pinagpahanap po would be yung sigma. Okay? So, ibig sabihin po, we have to express first C and I in terms of the dimension. Okay? Bawa, the thickness is A. Okay? We have to express C and I in terms of A. Tapos, yun po isa substitute dito. So, then basically, the procedure would be the same lang. Okay? So, itry na lang po siguro natin sa bahay. Okay? Ganun din naman po yung ating practice doon sa economic sections. Okay? Paano ba kukuhanan yung value ng C and I kapag economic sections? Okay? O halimbawa, mag-try kayo during your free time. Okay? Yung centrum A hanggang Z. Okay? How will you arrive at the values of their C and I po? Okay? So, nakuha po ba yung ibig kong sabihin? Yung kailangan yung i-recall, okay? So that you could answer po yung mga numbers under your appendix. Okay? Question? Wala na po? Hello. Okay, so I'll start po with a new topic po. Okay, saglit lang. I'll shift po yung akin na presentation. Okay, so let us this time po, okay, members under your torsion, okay? So when we say torsion naman po, these are four members that are rotating. So these are very common naman po kapag shaft, okay? So when we have yung shaft, we consider po yung dalawang configuration. It's either a solid shaft o kaya po ay yun po hollow shaft. Okay? So, yun po yung gagamitin po natin dito. Okay? So, when a member is under pure torsion, okay, it experience po yung torsional shear stress, and at the same time, it has its corresponding deformation din po. Okay? So, ang deformation niya naman po, ang tawag po natin is the angular deformation, or we say simply the angle of twist. Okay? Say for example po, this is po yung atin na shaft. Okay? So, if it is rotating po, okay, so ito po yung kanya na torque. So, ang mapapansin nyo po, if yung member niya po, say initially po ay horizontal na ganyan, okay, or vertical, okay, so kung ito po yung member niya, pag ikot niya po na gano'n, napipilipit, nagkakaroon po ng twisting. Kaya mapapansin mo, mamaya ay nandito na siya, nandun na yung parte na yun, nakaganon na siya. Kasi nagkaroon na ng twisting. Just like also, ito po yung ating original example, ito yung kanya na fiber, okay? So originally, horizontal po yan. Okay? Pero sa pag-ikot-ikot po, mapapansin mo mamaya ay nakaganito na siya. Okay? Nakahiris na yung atin na fiber. So you come up now with an angle. Okay? So yung pagbabago doon sa kanyang initial na position po, okay, that resulted to a deformation. Okay? So yun po yung deformation niya in a form of an angle. Okay? So yan po yung para doon sa members under your torsion. Okay? So paano po natin i-design ang mga members under pure torsion? Una po is basically doon sa kanyang strength failure, okay, at ang pangalawa is doon sa deformation failure. Okay, katulad po ito noong sa tension. Okay, ito po ba sa tension? Yun po yung naging basihan natin sa pagde-design. Isa ay galing sa stress at ang isa po ay galing sa deformation. Okay, so let us first recall yun po galing sa stress. Okay, so we call the induced stress simply as a torsional shear stress. Okay, so we have here po yung shear. Okay, torsional shear para sa umiikot. So for shear po, we use po this symbol. Okay, you call it tau. Okay, so yung tau po, yan ganun yan po yung itsura. Okay, so ito po yung tau. Okay, This will denote, okay, yung shear stress po natin. The general formula for a torsional shear stress equals TC over J. Okay? TC divided by J. J is called, okay, yung pong J natin, yan po ay polar moment of inertia. Okay? Polar moment of inertia ang J. And then, yung C naman po is called a radial distance. Okay? And yun pong atin na T would be, yan po yung torque po natin, or we simply call it as a torsional moment. Okay? So, ang tawag po doon is torsional moment. The value of the torque that is simply equal to the force you applied multiplied by the radius. Okay? So, yun po yung value ng torque. But then there are other ways on how you could obtain din po yung value ng torque aside from force times the radius. Okay? Now, so, unahin muna po natin is the value of the polar moment of inertia. Okay? Say for example po, we have a solid circular cross-section, okay? A solid shaft, okay? Having a diameter D, okay? Yung J po, if it's a solid, okay? Yung J po for solid is simply pi D to the fourth divided by 32, okay? Yan po yung kanyang value ng J. Kung siya naman po ay hollow, okay? And then we use a small d po for the inside diameter and big letter D for the outside diameter. Sa hollow po, J for hollow is equal to pi quantity D to the fourth minus D to the fourth, okay, divided by 32. Okay? So, yan naman po yung equation ng J for hollow. Okay? So, we go now dun po sa radial distance. Okay? Alin naman po yung radial distance? Pag sinabi po radial distance, it is any distance po. Okay? It is any distance mula po sa center. Halimbawa po, and, okay? Say for example, ito po yung center, okay? Any distance from the center, you call it po C or a radial distance. So, halimbawa po, pamula po doon sa center hanggang dito, okay? We can call it simply as C1. Okay? Pamula po dito hanggang halimbawa andoon, okay? You can call it simply as C2. Pero, ang hinahanap po natin palagi ay yung maximum value of C. Okay? So, what would be the maximum value of C? Okay? Pag kinuha po natin ang maximum value ng C, so that would be equal to the radius. Okay? Yung C maximum po natin ay equal sa radius. Okay? That is in the case of a solid shaft. Okay? So, ito po, solid shaft. So, C maximum equal to the radius. Okay? Why are we using the C maximum? Okay? Kasi pag kinuha po natin yung value ng stresses, okay, this will represent their stress po. Okay, so this will represent your stress, okay? So, ari po mga arrows na to, this will represent po your stress. Okay? So, what do you see po, say po, with the value of the stress? Halimbawa po, yung pong arrow ha, yung pong length ng arrow. Okay, ang minimin ko po as the stress. So, aray stress 1, stress 2, 3, 4, and then stress 5. Okay? And each one will correspond to a value of C. So, aray po ang C1, aray po yung C2, okay? C3, yan. Okay? What can you say about po doon sa relation noong ating shear stress with the value of C? Anyone? Ano po yung nakikita ninyo? Yes, Sir Dan.
Ano po, directly proportional
Okay. So, directly proportional. Ibig sabihin po na, okay, habang lumalaki po yung value ng C, nag-i-increase po yung value ng C, you look at the amount of stress, nag-i-increase din po. Okay? So, yun po yung ibig sabihin. That is why we are using the C maximum. Kaya C maximum po ang kinukuha natin kasi ang kukunin din po natin na shear ay yung maximum. Okay? So, yun po yung gagawin natin ngayon. Now, let us derive, okay, the torsional shear stress, maximum torsional shear stress for a solid shaft. Okay? For a solid shaft, okay, ano po yung J natin for solid? Pi d to the fourth divided by 32. Okay? And then, what about naman po yung C maximum? Okay? Ano yung C maximum if that is a solid shaft? Hello? What is
D
C
over 2 po, ma'am.
maximum? Correct. That would be D over 2 or the radius. Okay? D over 2. So, yan po yung ipapalit ngayon natin dito from the general equation. Tau is equal to TC over J. So, in place of C, palitan po natin siya ng C max. Okay? And in place of J, ari po yung ipapalit natin. Okay? So, we have there T. This is D over 2. And J would be pi d to the fourth divided by 32. Okay? So, we can cancel out po yung D and D to the fourth. 2 and 32, this will give you 16, ari naman po, D cube. So, having that po, simplifying, your tau for solid will be equal to 1? 16 T over pi D cube. Okay? So, instead po of using the general equation TC over J, pwede na po ari ang gamitin natin. Okay? So, for a solid shaft, ito na po yung kanyang induced stress. 16T over pi D cube. Nakuha po ba yun? Naintindihan po? Hello? Okay. So, we go naman po with a hollow one. Okay? So, sa hollow naman po, yan. Okay? So, kukunin natin ulit yung C maximum. Okay? So, kapag po siya ay hollow, okay, J for hollow is equal to pi quantity d to the fourth minus d to the fourth divided by 32. Okay? And what would be the value of your C maximum? C maximum po natin pamula sa center po hanggang dun sa pinakadulo. Okay? Yung pinakamadulo po o mataas po na value ng distance. Okay? So that would be equal to the outer radius. So the outer radius would be big letter D over 2. Okay? So with that po, palitan po ulit natin yung general equation. From tau equal to TC over J, hanapin po natin yung para sa hollow. Okay? So yung C po at yung J po na yon, ipapalit po natin yung C max at J for hollow. Okay? So we come up now with T. Ang C po ay D over 2 at ang J po is pi D to the fourth minus D to the fourth divided by 32. Again, big letter D po pertains to the outside diameter and small letter D is the inside diameter. Okay? So what can we cancel naman po this time? Ano po yung ma-cancel natin diyan?
Yung pong 32
Yung
and
2
2
po,
po.
32.
Okay, 2 and 32 lang po ang pwede natin ma-cancel. We cannot cancel po yung diameter this time. Okay? So, simplifying that, ano na po yung magiging equation natin? Your tau of H would be equal to 16, okay, 16 TD. Okay? Over pi quantity d to the fourth minus d to the fourth. Okay? So, ito ngayon po yung gagamitin na natin. Instead of TC over J, if we know that the shaft is hollow, alin na po yung ating magiging equation. Okay? So, these two po, these are your induced stresses now. Okay? So, ano po yung gagawin natin sa design to obtain the dimension? So, we say, for a good design, equate the design stress to the induced stress of the material. Okay? So the induced stress is tau, say, of the solid, then the design stress would be tau D. Okay? So notice that since yung ating induced is in form of tau, so ang design stress should be in tau also. Okay? So yun po yung ating tatandaan. Dapat po parehas. Okay? So kung solid po iyan, then we say this is equal to what? 16T over pi dq equal to tau D. This can be tau U over factor of safety. Pwede din po na tau Y over factor of safety equal to 16T over pi dq. Kailan po gagamitin na ring equation na to? Aring una. Hello? Kailan po gagamitin? If design
Solid po yung ating
in terms of
is okay. Correct. Okay. Pag solid po and at the same time, design is based on the ultimate strength. Kaya ang ginamit po din ay tau U over Fs. Okay? At ito naman po padalawa, gagamitin mo po yan if shaft is solid and at the same time, the design is based on the yield. Okay? Pag wala po sinabi as the basis of design, again, susundin po natin yung type ng material. Okay? Ductile for yield. Okay? Yung po namang ultimate para po yun sa brittle material. Okay? So, ito po yung gagamitin natin. Kung siya naman po ay hollow, okay, then tau D equal to the tau po ng hollow. O, yun po yung equation natin. Ito po, okay, 16TD over pi quantity d to the fourth minus d to the fourth. Okay? Equal to your tau D. Again, yung tau D mo, pwedeng tau U over Fs, pwedeng tau Y over factor of safety. Depende sa basis ng design. Okay? Ang tanong lang ngayon ay, saan ko ma'am kukunin yung factor of safety? Okay? So, the same lang din po sa table 1.1. Okay? Doon pa rin po. Same conditions are to be applied po para po makuha mo yung factor of safety. Okay? What about naman po yung tau U at tau Y? Okay? Yung tau U at tau Y po, hindi naman po yun nakikita exactly sa design tables po natin. Okay? So, saan po makikita yung tau U at tau Y? Okay? You need to solve for them. Okay? So, the value of this tau U and tau Y, it is dependent on the value of sigma U and sigma Y. Kaya, sa material specification po natin, sigma U and sigma Y pa rin po yung kukunin po natin. Okay? So, you need to solve lang po for the value. You have here the relationship po. Tau Y is simply equal to 0.6 of sigma Y. Okay? So, yun po ang gagamitin. Your tau Y is equal to 0.6 of sigma Y. And your tau U would be equal to 0.75 of sigma U. Okay? So, yun po yung gagamitin dito. Then, divide by the factor of safety to come up with the design stress. Okay? Maliwanag po ba tayo doon? Hello?
yes po ma'am.
yes po.
Yes.
Okay? So, yung procedure po na ito, yan po ay designing, okay, against the strength failure, okay? So, you would have there your answer po. What would be your diameter, okay? So, designing based on the strength failure po, okay? You equate the design stress to the induced stress of the material, which is the torsional shear stress. Kung siya naman po ay hollow, okay, there would be a given relationship between the outside and the inside diameters. Okay? So, yun po ang gagawin po dito. Okay? And then, kanina po may minention din ako, okay, na meron po siyang deformation failure. Okay? You can have the design po base din sa deformation failure naman po. Okay? Sa deformation naman po, ang tawag mo sa kanya is the torsional deflection. Okay? So, ang tawag po sa kanya, torsional deflection, torsional deformation, or simply, angle of twist. Okay? So, yan po yung tawag. Okay? It's the angle of twist. Ito po yung sinasabi ko kanina that if you have here initially a horizontal member, pag ikot po siya ng ikot, nangyayari na napipilipit po. Okay? Kung baga, ito siya kanina, ito na yung final position niya. So, pertaining to the initial position, you come up with an angle of twist. Okay? So, yun po yung mini-measure natin as the deformation of the member. Okay? So, we compute po for this angle of twist using the equation theta equal to TL over JG. Okay? So, this theta, it refers to the angle. Okay? Equals sa TL over JG. Torque. L pertains to the original length. J is again the polar moment of inertia, and G is the modulus of rigidity. Okay? And anong ginagawa po natin sa design? Katulad po sa tension, okay? We equate simply your allowable limit, okay, of the deformation to the computed. Okay? So you equate here the allowable limit of deformation to the angle of twist, TL over JG. Okay? Yung theta po natin dito, this is in unit po na radians. Okay? It is in radians. Paano po natin nalalaman na radians yan? Pag sinubstitute mo po dito yung torque, okay? O, tapos po yung length, yung J at saka yung G, sama-sama yung kanilang unit. Okay? Pag na-cancel out po yung lahat ng unit, okay? Pag na-cancel out po yung lahat ng unit, wala pong natira, okay? That is the time you'll say it is in radians. So, tama po yung iyong ginawa. Pag na-cancel out po siyang lahat, walang natira sa mga unit na yon, radians po iyon. Okay? And if you wish to convert that in degrees, okay, you have there pi radians, okay, is equal to 180 degrees. So, yun po yung gagawin mo, conversion, kung gusto mo pong i-change siya into degrees. Okay? Again, ano lang po natin, kailan po siya radians? Pag na-cancel out po natin lahat. Okay? Kumaga, may unit si torque, may unit si length, ganon din yung J, pati yung G. Okay? So, meron siyang kanya-kanyang unit. Tapos, pag tinignan po natin, sinubstitute po natin, and na-cancel out po lahat, yun po ay radians. Okay? So, radians po yung magiging, ano po natin, unit po doon. Okay? So, pag hindi po yan na-cancel out lahat, o halimbawa, merong hindi ka na-cancel, o ano pong ibig sabihin noon. Okay? So, baka may hindi ka po na na ipalit or na i-convert na unit. Kaya hindi mo po na-cancel out. Okay? So, kailangan po pilitin mo na ma-cancel out lahat. Okay? Titingnan mo, yun po yung palatandaan natin kung tama ba yung solution mo. Okay? Kailangan yung unit niya ma-cancel po lahat. Otherwise, ano po yun? Senyales po yun. Okay? Senyales na ano? Ikaw yung matitira. Okay? Matitira ka sa machine design 1. Okay? Kasi, may natira doon sa iyong unit. Dapat makakancel lahat. Okay? Nagkakaintindihan po ba tayo? Question. Hello?
Wala pa naman po.
Okay. So, wag po nating naisin na matira sa machine design 1. Okay? So, dapat po makancel lahat. Okay? That is in radians. Okay? Now, anong gagawin natin? Okay? We are to equate this angle of twist to the allowable limit of deformation. Okay? And then, using this, equating this two, you will arrive at another answer. Okay? You will arrive at another answer. Parang yung pong doon sa ating sa tension. Meron tayong answer from the strength failure, meron po tayong answer coming from the deformation failure. Okay? So, ganun din po dito. Okay? But then, not at all times, there will be your solution para sa deformation failure. Okay? Nagkakaroon lang po nito kung given po itong isang ito. Okay? The allowable limit of deformation. Okay? Kung wala pong given nito, ibig sabihin, wala po tayong solution, okay, coming from the deformation failure. So, our answer will be based only doon sa strength failure po natin. Okay? Now, let us derive po yung theta or the angle of twist kung siya po ay solid shaft. Okay? So, kung solid po yan, yung pong J na yun po yung papalitan natin, okay, applicable for a solid shaft. Okay? So, ano po yung J na yon kung doon sa solid. Okay? So, i-recall po natin, ginamit na po natin yung kanina. Yan. Pi d to the fourth over 32. Okay? So, we have here now TL over J is pi d to the fourth divided by 32. Then you have there G. So, simplifying this, theta for solid, okay, would be equal to what? 32 TL over pi d to the fourth G. Okay? And ito po yung i-equate natin to theta limit. Kung yan po ay solid. Okay? Kung hollow naman po, okay, papalitan ulit natin yung J for hollow. So, theta for hollow would be TL over pi quantity d to the fourth minus d to the fourth divided by 32 times G. Okay? So, simplifying, theta for hollow would be 32 TL over pi d to the fourth minus d to the fourth, then multiplied by G. Okay? At yun po yung equate natin to the allowable limit of deformation. Okay? So, you would come up with your answers po here. Okay? So, dalawa po yung magiging sagot natin. Okay? Isa galing sa strength, isa galing sa deformation. Then, you must have your conclusion. Therefore, you use, alin po yung pipiliin natin? Again, the bigger dimension. Okay? So, pipiliin mo po kung alin yung mas malaking dimension. That would satisfy both the strength and the deformation criteria po. Okay? So, lagi po, bigger dimension that wins. Okay? So, yun po ang tatandaan po natin. Okay. Now, meron po dito mga nakanote. Okay? If length is not given, you can assume to use a length, okay, equal to 20 times the diameter. Ari naman po ay na-mention ko na sa inyo nung pong ginamit natin siya sa compression. Okay? Again, you can make use of this po. And then, for the value of G, this is the modulus of rigidity. This is the same naman po doon sa modulus of elasticity. Okay? Ganon din mo po siya hahanapin. So, given the material, so sa table mo muna po titingnan. Okay? For the particular material. Okay? Pag wala po doon sa hanay ng material, ang sunod mo pong titingnan would be yung heading ng table. Okay? Baka po may minention doon na value ng G. Pag wala pa rin po, okay, assume to use this value. G equal to 12 times 10 to the 6 PSI or 12 times 10 to the 3rd KSI. Okay? So this is a general value or a standard value, okay, for all types of steel. Okay? Yan po yung pwede natin gamitin. Okay? Kung wala pong data coming from our design tables. Okay? So yan po yung gagamitin for the value of G. May tanong po ba tayo? Hello?
Wala pa.
Yes, Eric.
Ma'am, if wala pong given na allowable limit po, sa strength failure lang po ulit magbe-base.
Yes po. Yes po.
Okay po ma'am, thank you po.
Okay. So, basically, the same po yung procedure na doon sa tension. Okay? Strength and deformation failures ang kinoconsider po natin dito. Okay, so let us have this now, okay? So we recall here power formula, okay? So meron po tayo dito na power formula. Ano lang po nito, paki-erase lang po dito yung 2 pi. Okay, aalsin po natin dito yung 2 pi, okay? So this is simply Tn over 63025, okay? Ano po yung gamit ng power formula po natin, okay? The power formula, this is to be used po, okay, in solving for the torque once you are given po power, okay? Pinakamalimit po gamitin dito are these two, okay? So, i-asterisk na lang po siguro natin, ari pong dalawa, okay? Yung dalawang huli, okay? So, ginagamit po iyan to solve for the torque, okay? Ang focus po natin dito is to obtain the value of the torque, okay? If you are given the power, okay? Power given, you solve for the torque, okay? So let us have this two. Dito po tayo sa dalawang pinakamalala gamitin, okay? Ari po pangatlo, ari po ay gagamitin kapag SI po yung ating system na ginagamit for solving, okay? At ari naman po, ari po yung para sa English unit, okay? So English unit, ari po yung metric or SI, okay? So power is equal to 2 pi Tn over 60. Ari naman po isa, Tn over 63025. Okay, so let us have first po yung power po dito. Okay, kunin po natin yung equation na yon. Bawa, power is equal to Tn over 63025. Okay? So again, gagamitin po natin ito to solve for the torque. Okay? So therefore, coming from this, yung torque po natin will be 63025 times the power, okay, divided by N. Okay? Torque is T. Yung N po would be the speed in revolutions per minute. Okay? So ito po dapat yung kanyang unit, RPM. Okay? Revolutions per minute. Okay? At yung P po na yon, yung P po, power, okay? There are different units po ng power. But then using this equation po, dapat po yung power natin dito is in HP or horsepower. So kapag ginamit po natin yung equation na yan, torque is equal to 63025. P should be in horsepower. Okay? Divided by N in RPM, you will yield po your answer in unit pound inch. Okay? Ang makukuha mo kung sagot is in pound inch. Okay? Ang gawin nyo lang po, i-divide mo po by 1,000 para ma-convert po into kip inch. Okay? Kip inch. Kasi yan po yung pinakamalimit natin gamitin. Since the values of the properties are in KSI, yung nasa table. Kaya, ang answer po din i-divide mo po ng 1,000 to be converted into kip inch. Again, kailangan po sundin nyo yung unit, okay, requirement for P at saka N to come up with this value. Okay, and N is in RPM. Okay? Ano po ba yung ating mga units ng power? We have horsepower, we have watts, kilowatts, yan po yung pinakamalimit. And if you wish to convert that to po, 1 horsepower is how many kilowatts? Hello?
0.746 po.
746 po.
Okay. 0.746 kilowatts. Okay. Yan po yung conversion natin. Okay? Yan. So, kailangan po, pag ito po yung ginamit natin, power is in HP and N in RPM. And your answer is in pound inch. Okay? Yun naman po pangatlo. Okay? Ari po, mag-focus na lang po tayo din sa dalawang ito. Kasi yan po yung pinakamalimit natin na gamitin. Okay?
50 pounds.
Okay, so paano po naman kapag po ito? 2 pi, okay, power is equal to 2 pi Tn over 60. Okay? We need therefore value ng torque. Okay? So given the power, ano po yung equation natin? That would be 60 times P divided by 2 pi times N. Okay? Kailangan lang po, alam po natin ang unit ng power at saka yung unit ng N. Ang N po dito, the same po, RPM. Okay? Pero yung power po dito, this is in kilowatts. Okay? Tatandaan po. Ang power po dito should be in kilowatts pag iyo po siyang isinubstitutean. Okay? And you can have your torque po in unit kilonewton meter. Okay? Yan po yung unit ng torque po natin dyan. Okay? Na masosolve po natin. Okay? If you use power in kilowatts and in RPM. Again, the power formula, okay, gagamitin mo lang po iyan to solve for the torque po. Okay? That is to solve for the torque. Okay, question? Hello?
Ulit lang tayo ng ulit yan.
Ang tanong po?
Wala naman po.
Wala naman. Okay. Let us have this one. Wait lang. Oh, nasulatan ko pala. Okay, anyway. You look at problem 2. Okay? Never mind po aring solution dito sa baba. Okay, never mind this one. A mean power transmitting shaft, okay, of cold finish AISI 1118 transmit a torsional moment of 1,200 pound each. For a medium shock, what would be its size if the deflection is not to exceed 1 degree for a length of 10 feet. Okay? You try to answer po problem 2. Okay? So, ilagay ko lang po din yung given. Okay? And then, you follow po yung procedure natin ulit sa design. Given, material specification, factor of safety, design stress, then equating. Okay? So, here, meron po ito na strength failure and at the same time, meron pong deformation failure. So, paano ko po nalaman na may deformation failure? Ito po yung magic word. Deflection is not to exceed 1 degree. Okay? So, yan po ang magic word na nagsasabi sa atin na meron tayong deflection failure or deformation failure. Okay? So, dalawa po yung magiging sagot natin dyan. Okay? One coming from the strength failure, another one coming from the deformation failure. Okay? So, kuhanin niyo po yung dalawang sagot na iyon and then have your answer po, okay? Pipiliin yung mas malaking size. Okay. Let us have first the given values. Okay. So, we have first the torsional moment or the torque. Okay. This is equivalent to 1,200 pound each. Or, converted to kips, that would be 1.2 kip each. Okay. And then, ano pa po yung given? Deflection not to exceed 1 degree. So, yan po yung tinatawag natin na data limit. Okay? Equal to 1 degree. Ang gagawin nyo po, you convert it na po to radians. Okay? So, 180 degrees is equal to pi radians. Okay? So, cancel out mo po yung degrees. So, you'll have your answer in terms of radians. Okay? And then, length of 10 feet. Okay? L is equal to 10 feet. Okay? Yan po yung given. And then, go with material specification. Okay? 1118. Okay? Tapos po, find value of sigma U and sigma Y.
8 degrees na lang ang angle ni 50 kay incline. Did you get it?
1118 cold finish.
Nakuha po. O yan.
sigma
O,
U,
na-drawing nyo na si 50 pounds.
sigma Y. Okay? Pwede mo rin pong isama na dyan yung value ng G kasi kukunin din naman natin doon sa table. Okay? So, yan po yung mga values po natin for material specification. Tapos po, you follow na yung ibang procedure. Factor of safety, design stress, okay? So, pakihanap po natin yung sagot po for this example problem 2. Nasundan po ba yung gagawin? Alam po yung gagawin? Hello? Okay, dalawa po yung sagot natin ha. Isa po ay galing sa strength failure, ang isa po galing sa deformation failure. Sige po, you try solving it muna po. Okay, Almac, noted. Just i-note mo na lang din po doon sa attendance po natin. Okay, thank you.
Opo, thank you po.
Okay, everyone, you try solving po for the sample problem.
Kaya po,
na. Okay. Reniel? Done ka na?
So, concurrent sila.
Hello, Reniel?
So, basa ka ng letter E.
Hello? Narinig po ako?
Left or right?
Rinig po, ma'am.
Okay, Reniel, nakatapos ka na? You raise your hand.
Ken Clark.
Hello?
How about letter M?
Wala.
First quadrant, third quadrant. Alfonso.
Sino po nakatapos na? Yes, okay.
Verse.
Daniel, kindly post
How about
your
letter
answer
I?
dito sa
Second or fourth?
ano natin,
Angle verse.
sa Jamboard natin doon sa slide 20. Okay,
How about
para
the weight?
i-discuss po
30
natin.
Newton. Anisha.
Paki-paste na lang doon sa slide 20, bakante pa naman.
Patulay.
Okay, Reniel, pasuyo, paki-ano natin, paki-discuss po natin yung solution natin. Reniel,
Mr. Clark.
hello?
Juliet. Okay.
Hello,
each
Raniel?
one is opposite. Kung si letter
Sir,
I
sira po ang mic ni Mr. Makuha.
ay pa-set, pa-fourth quadrant,
Sira po ang mic. Hindi po lang po maririnig po kahit po kami.
Ken Clark. Iya.
Okay, sige po. Pakibilisan lang po.
Audible na po ba ako, ma'am?
Okay na. Sige.
Opposite.
For the given po, T is equal to 1,200 LB in is equal to 1.2 kips inches po. Then yung pong degree po ay 1, ay go-convert na po natin sa ano po, sa degree, sa ano po, sa rad po. Though, ang magiging sagot po dyan po ay 0.01745329252. Then ang land po is equal to 10 feet. I-convert na po natin sa inches. 10 feet is 10 feet times 12 inches over 1 feet is equal to 120 inches. Then let's go naman po tayo sa material specification po. Ang ating po materials po ay AISI 118 cold finish. Then ang ating pong sigma U is equal to 80 KSI. Then ang sigma Y po ay 75 KSI from table 87, page 14. Then ang ating pong gagamitin G ay 11.5 times 10 raised to 3 KSI. Then yung ang FS po natin is equal to 3 from table 1.1, page 1 po. Then let's go naman po sa design stress. Tau D is equal to tau Y over Fs. Ang tau Y po is equal to 0.6 times OY times sigma Y po, ma'am. Then equals to 0.6 times yung 75 KSI over 3 is equal to 15 KSI. Then sa stress failure naman po is equal to tau D is equal to tau. So ang inasyon ko po siya na po ay solid po siya. Kaya po ang ating ginamit ko po ay tau D is equal to 16T over pi D cube po. Then sinab ko po yung value is equal to 15 KSI times 16 times 1.2 keeps inches over pi D cube. Is thus po ang D po is equal to 0.7413444,359 inches. Then sa deformation value naman po ay yung pong limit equals to TL over JG na equals to 32 TL over pi D for G po. Then sasab lang po yung mga value na 0.017 per pi 329252 is equal to 32 times 1.2 kiss inches times 120 inches over pi times d to the 4 times 11.5 times 10 raised to 3 KSI. Then ang magiging sagot po niya ay 1.644170484 inches, say 1 3/4 po sa inches po.
Okay, thank you, Reniel. Okay, yung iba po, may question po sa solution po ni Reniel.
Sa drawing ninyo yun ha. And then the fourth ninyo, sure ka na?
Okay, so I would like to comment lang po dito sa work po ni Reniel, okay, para po alam nyo na din po yung mga gagawin. So may ipapa-add lang po ako dito kay Reniel. Okay, so ano po yung mga i-add natin? Okay, let us have this first. We have first po yung data po natin doon sa given. Okay? So it is not simply data po, but rather dapat po ang ilalagay natin dyan is data limit. Okay? So magkaiba po yung dalawa. It should be data limit po ang nakalagay. Okay? And then for material po, okay lang po yun. But then on the factor of safety, ano po ang kulang natin ditong ilagay? You have to include here the conditions. Okay? Ano yung conditions? The type of load, medium shock. Okay? Ano pa? Based on the yield. Okay? Basis of design is based on yield. Why? This is a ductile material. So yun po yung dapat nandun na tatlo. Okay? Yung tatlong condition. Type of load, that would be the medium shock. Type of material, ductile, and basis of design based on yield. Okay? Dapat po nakalagay po iyon before the factor of safety of 3 ay mag-appear dito. And then after F is equal to 3, lagay po sa katabi table 1.1 page 2. Okay? So tatandaan po ha. And then you have here the design stress, correct? And then strength failure, you equate. So tama po ito. And then deformation, ito din. Okay? This is the answer for the deformation. Okay? After the deformation, the answer po, tsaka po tayo maglagay ng conclusion. So try to include your conclusion. Therefore, use diameter equal to ito pong atin sa deformation and then the standard size. Okay? So siguro sa pagmamadali namin Reniel, kaya hindi na i-include yung mga yun. Okay? But then sabi na natin, Need po natin yan kasi this is design, okay? We need conditions, we need those baseline data, okay? How we come up with this dimension. Okay, nakuha po ba? Daniel, na-follow mo yung sinabi ko?
Yes po, ma'am.
Okay. So the others, you do the same. Kung gano'n din po yung ginawa ninyo, may yung po mga sinight ko, pakilagay nyo po doon. Okay? Yun po ay mahalaga na mapalagay doon. Okay? Otherwise, sabi ko nga po, ay baka hindi tayo mabigyan ng points pag po hindi natin finalo yung procedure. Okay? So I think it's time already. So kung may question po tayo, you can raise that po siguro by next meeting po natin. Okay?
Sa dalawang
So I'll stop the presentation now.
gawa ninyo. Yung una,
Okay? So I'll end then the meet. Tawag dito, pangalan nito, Alma.
and
You, ano na lang, you take charge of the attendance for today. Okay?
Yes po, ma'am.
Hello? Okay, thank you.
Thank you po.
See you yan, see you yan.
Okay, namin diskarte.
Thank you.